Okay, what we want to talk about today are systems of equations. Systems of equations are created because we have two different variables that need to be solved for. If you have two variables, you need two equations in order to solve for them. If there were three variables, you'd need three equations. Four variables, four equations. We're only going to concentrate on the ones with two variables. With this system, we have 2x plus y on one side of our equation for our first one, but the second equation, it's y equals. We're going to solve by what's called substitution. Now, we're doing this one first because we've already dealt with the property substitution. So we're going to look at y is already by itself. So in each of our equations, one of the equations is already isolated. So y equals 3x minus 16. We're going to go into the other equation. So we're going to name these 1 and 2. In equation 1, we're going to rewrite 2x plus, but instead of y, everywhere we see y, we're going to plug in everything that it says. So I'm going to open up a set of parentheses. I'm going to plug in 3x minus 16, and I'm going to bring back now the equals 9. I put the parentheses here so that I can show that I have plugged something in and replaced the original variable that was there. The system work now is essentially finished, and what we want to do is we want to go ahead and we want to work with simplifying. So on one side of our equation, we just want to combine like terms. So 2x and 3x add up to 5x, and we're left with 5x minus 16 equals 9. So now we've got one step left after we add 16 to both sides, and we're going to be left with 5x equals 25. After we divide, we end up with x equals 5. Now that only solves for one of the variables, but if you look back up here, it's already set for us to plug in again, substitute in again our 5, and it will solve for y. So down here, what we're going to do is we'll take equation 2, and we'll go ahead and we'll plug in y equals 3, and instead of x, we're going to plug in our 5 minus 16. Simplify, and we find y to equal negative 1. So we have y equals negative 1, x equals 5, and when we write the solution for our system, the solution would be written as negative 1, comma 5. Again, this is by substitution. We plugged in for the variable what they told us it stood for, showed it by using our parentheses, substituted in again to find the next one. Solving systems by elimination, the first thing we want to look at is that we have x's and y's lined up above and below each other. Notice this time, unlike substitution, all on one side of the equation are x's and y's. The next thing that we want to look for is that above or below with our x's or our y's, you have exact opposites. In this case, our x terms, one's a positive 2 and one's a negative 2. So this step with elimination is actually very quick. We don't have to adjust anything. The minute we see exact opposites, we are going to add or combine straight down our system. In doing so, this will cancel out. 2 minus 2 does go to 0, but 3 plus 5 will give us 8y. Equals, when we add straight down here, 16. One-step equations created now. So when we divide both sides by 8, we end up with y equals 2. Now because we are using elimination, we have to go back up to one of our equations, and we have to decide where do we want to plug in y equals 2. Doesn't matter which equation you want to plug it into, pick the one that looks easiest. I'm going to go ahead and pick the first one, which was 3, and instead of y, we're going to plug in 2, plus 2x equals 6. 6 plus 2x is what this simplifies to, and solve our two-step equation. Subtract 6, 2x equals 0, and after we divide both sides by 2, we quickly find x equals 0. So we have our x value, our x coordinate, which is 0, our y coordinate, which was 2, and again, just like we did with substitution, you list your answer as an ordered pair, 0, 2. Final answer. Okay, now instead of elimination where there was just one step, or substitution with systems where we immediately plugged equations in, we're going to solve for two variables using two equations, which is why we need a system. But this time what we have to look for is that we don't have exact opposites. In the last example, we immediately saw that our x's or our y's were exact opposites. One of them was positive, one of them was negative. Here we have a -4 and a 1, a +2 and a +1. Using elimination, when we combine straight down, none of them are going to cancel out. So what we have to do is we have to make them exact opposites. And I've numbered our equations here so that I don't mess up anywhere or mix anything up. Easiest equation to change is going to be this bottom one, because these numbers are 1, and I can multiply anything and make them match up with our 4 and our 2. 2 is the smaller number, so the only reason I'm going to pick to get rid of or eliminate my y's first is because 2 is smaller. In order to do that, I want to make this value -2. I'm going to multiply the entire equation by -2. That way, not only will x change, y change, but also I have to remember to change this last number here because I want it to keep equal. So I'm going to rewrite my equations, leaving the top equation alone. I've not changed anything there. And now I'm going to distribute my -2 to everything across the next equation. So this now changes to -2x minus 2y equals -8. Now when I look at my variables, these are still different, but a +2 and a -2 are the outcome here. Now that I have exact opposites, I'm going to go ahead and add straight down, combine straight down. The y values are going to cancel because a +2 and a -2 cancel out. And I'm left with -6x equals -6. After dividing by -6, we end up with x equals 1. So just like in the other two examples, I now have one of my variables, and what I need to do is plug it back in and find the next variable. Now I can plug it back into either of these, but I think we can all agree, again, this one's the easiest one to work with because there's the least amount of multiplying going on. So we're going to go ahead and substitute in for x, our 1, and again, it's just a number, but I want to show that I substituted it in, plus y equals 4. Again, I plugged it into this equation so that I could figure out what y is. So 1 plus y equals 4, and when I subtract 1 from both sides, we end up with y equals 3. So our first one, we changed the equation so that we could eliminate to find x is 1. The next time we plugged in x so that we could find y is 3. And again, we write our final answer as an ordered pair, 1, 3. Remember, with systems, the whole reason we're solving with two equations is because we have two variables, and we have to make sure that we solve for one and then the other.